Hello everyone, a very good evening. Welcome to the final day session. Hello ma'am.
Hello, sir.
Yes ma'am, we can start the session please.
Okay, sure. Okay, my screen is visible.
Yes, it's getting, yes, visible now.
Yeah. So in yesterday's session, there is a one question that can we do the a priori algorithm or the association and correlation using R. That is also the one feature of the data mining. Okay, so let's we start with first the a priori algorithm that is used for finding the correlation and association between data set. And there is a one term that we already discussed, that is a market basket analysis. And that market basket analysis is used in a superstore to extracting the different rules that if a customer is purchasing a one product, then what is the probability of purchasing the other products in the same cart. Okay, so let's begin this session with this a feature of the data mining, that is association and correlation analysis that we already discussed yesterday, but not covered practically. Okay, so for that, we first start with one inbuilt data set. That data set name is a groceries data set. Okay, that data set is available with R to perform the association and correlation analysis. We required three different libraries. The first is our rules, that is used to make a rules. Then to visualize the rule, we required a rules wish library, and to make some customization in the graph, we required a R color viewer library. So these three libraries we required, I already installed in my system. You can see this rules wish, and the next is a R color viewer. Okay, so these are installed in my system. For installing, you can just write install.packages and the name of the package, and the library is get installed. So first, please install this so that you can perform the different association analysis. Okay, so for the association analysis, someone yesterday sent me one question that there is a different threshold value, it's a minimum support values, confidence level, and on the basis of the confidence and the minimum support level, we have to identify what are the different rules that are defined by the a priori algorithm. Okay, so let's first understand what this data set is, how this data set is look like. Okay. So if I just uh, uh, click on this data groceries, let's just write. This is this I am going to uh, getting the properties of the data set. So you can see in the data set, this data set is the transactions. Okay. So what do you mean by transactions? That there is a one, for example, I see, let's give you an example that which type of data set this is, because this is not uh, printable in the printable format. We cannot see what the data set is. So I just give you a one quick overview that how data set look like. Okay. So for example, if there is a customer one, And when we are going in any shopping mall and billing our product, so we get a one customer ID. Okay, so there is a one customer ID in our data set, and next there is a products. Okay, so for example, my customer ID is 001, and I purchase three products like bread, butter, and milk, for example. Means these three products are in my cart. Okay. For example, there is a second customer that ID is a 002, and he or she is buying bread with curd, with like jam, and he or she also buys, for example, there is a rice with that. So it might be possible that one customer has minimum one product, and the number of products may vary from customer to customer. So in the groceries data set, there are means 5,000 transactions. So this one record is called as one transaction. Okay. So similarly, in the groceries data set, there are lots of the transactions are available. And on the basis of that, we have to first find out which products are most frequently buy by the customers. And if a person is buying bread, then what is the probability that customer is buying the jam also? So we have to make relationship, and we have to find out the correlation between the product like bread and jam. Okay, so these type of analysis we have to do with this a priori algorithm. So this type of data set we have. Okay. Now, if we want to do this in a RStudio, so we have to first make a rules. Okay. So to making a rule, we have to use this a priori method. Okay. This a priori method, in this a priori method, we have to find out, we have to pass the data set. Okay. This is our data set. Now, we have to pass what is the support value and what is the confidence you want to take. Okay. It depends on the manager, or it depends on the analyst who is going to develop the rules. Okay. But if your support value is increasing, numbers of rules are decreased. Similarly, if your confidence value is increasing, the number of rules are less. So if you want to make 10 rules, 20 rules, 30 rules, according to that, you have to decide what is the support and confidence value you have to take. Okay. These support and confidence values are in two forms, either in the form of the frequency or either in the form of the probability. Mostly when we are using in any programming language, then we have to pass this support and confidence as a probability value. It means this support and confidence value lies between 0 and 1. Okay. So this a priori method is used to make a rules. Then it depends on the data set, depends on the support value, and depends on the confidence value. Depending on the confidence value, the numbers of rules are developed. But if you want to check any the first 10 rules defined by the algorithm, a priori algorithm, then you have to use this method inspect. And in inspect, you can see that I pass rules. This is the rules variable, and I pass 1 to 10. It means it gives me 10 results that are most frequently, 10 rules that are most frequently used by the that are used most frequently developed by this algorithm. Okay, let's see what is happening here. So I just run this code. Okay, you can see that Okay, you can see that it gives you a priori specification parameter. It gives that we pass is the confidence value 0.2. Okay, so it and support value 0.01. It uh, means tried to develop a rule maximum 5 times, and in every rule at least there is one product. If there is no product, we cannot make a rule. Okay, and in this algorithms, the absolute minimum support count means reached is 98, and shorting and recording records done 88 times. There are 169 items totally, means 169 products in groceries data set, and there are 9,835 transactions. Okay, so means total 9,835 rows are there. Okay, so this is the details about the data set. Now, if we want to print the rules developed by the Astronomy algorithm, we have to just click on this. You can see that what are the different rules. You can see that the rules from 1 to 10. Because we are printing 1 to 10. If we change this number, then these rules are also changed. Okay. So you can see in the first rule, there is a product that is a whole milk. Okay. With support value this and confidence value this. And these support and confidence values are always greater than the support and confidence value given by us in the programming. You can see in the programming, we are giving support value 0.01, confidence 0.2. And you can see the result. All support values are greater than 0.01 and confidence is always greater than 0.25. Any rule, if developed by the system that has the support value and confidence value less than the support value provided by the programmer, then these rules are extracted or dropped. Okay, so we have to check that we have only derived the rules that have the support and confidence value given by us. So we have to check if it might be possible that we give a support and confidence value so that no rules are developed. In that case, you have to change the support and confidence value to develop the rules. For example, if in my question, for example, if question I change this and I change this 0.02. Okay, and confidence is 0.3. Let's see what happens. Okay. Now see, all the values, support values are greater than 0.02 and confidence value is greater than 0.3. You can see. Okay. It means that depending on the value, support and confidence value given by us, the rules are developed. Okay. So what this support values, confidence value gives us that if a person is purchasing a frozen vegetable, then he or she can buy a whole milk. The probability of sale is 0.0429. Similarly, if a person is purchasing a curd, then what is the probability that he or she is purchasing a whole milk is 0.49. Okay, so that's in this way we can interpret the result of the Astronomy algorithm. Okay, Now, if we want to visualize the result, means what are the visualization results, then for visualization plotting, we have to do a plot of frequency plot. Okay. So in frequency plot, if you want to plot 20 most occurred or most purchased product, then you have to write top 20. If you want to change that top 10, top 5, top 25, you can change this. Okay. This just gives you a top purchasing product. Okay. From the given data set. Okay. And here this is a just color pastel where there are various types of the colors are there, and this main is for the giving the name of the frequency plot, and the type is a relative because we are plotting the frequency, relative frequency, and in y-axis we have to uh, give the name that is the item frequency relative plot. Okay. Now, if I run this code, you can see this plot is different. Okay. These are top 20. Okay. Now, if I want to change this to top 10, okay. So, I can make here changes 10. Okay. You can see these are the top 10. Yes, this data set groceries is inbuilt in our studio. This is the inbuilt data set. We don't want to import that data set from anywhere. This is available with R. But if you want to do this with the CSV file, then you can, this data set is also available in Kaggle that I already discussed yesterday. So from there, you can download this data set also. Okay. Can I send this script if required? And you can change the support and confidence value. For example, I also gives you example. If I change this confidence value, for example, 0.5, let's what happens. It might be possible the rules are not developed because this confidence is very high. You can see this is the error that there are no 10 rules. Rules are not developed. So you have to choose this support and confidence value in this way that the rules are developed. Okay. Because our main objective is to develop the rules. I am just sharing this script to you. If any doubt in this, because that is asked by some participants in yesterday lecture that can I cover this? So that's why I am going to cover that in today's lecture. Okay? If any query in this, then you can ask. Otherwise, I can begin with the clustering. That is another feature of the data mine. Hello. Okay. So let's start with another feature of the data mining, that is a clustering. Okay. Hope I see PPT. Okay. So first feature of data mining uh, is that we discuss in today's lecture, that is the association and correlation analysis. The second thing we already discussed yesterday lecture, that is a clustering. Okay. And the third and the main function also we can say is um, uh, in yesterday lecture we discussed classification. Okay. And the another function of the data mining is a cluster analysis. Okay. So what is the first difference between a classification and clustering? Okay. So in yesterday lecture, I already tell you that to apply classification algorithm, it is compulsory that you have at least one dependent variable. For example, if we are taking a one data set, that is the iris data set. Okay. In the iris data set, we already see that there are 4 independent columns and there is a one dependent column is species. Okay. And dependent column has the categorical values like Sentosa, Virginica, and Versicolor. Okay. But these labels are already defined to us. It means if we classify the data set is divided into how many parts? Only 3 parts. Because we have only 3 label of the classes. Okay. But in real life, it might be possible that these class labels are not known to us. We don't have idea that how many classes can be derived. Okay. For example, if one can say that there is only 3 criteria in passing, like pass or fail. But it might be possible pass with this percentage, fail with this improvement. That classes can be created. But if we predefine the class label, we cannot create another classes in another attempt. Okay. So when we use the cluster analysis, when we don't have the dependent column. Okay. We have only independent column. We don't know how many classes can be derived, how many cluster can be formed. In that case, we have to use the cluster analysis. Okay. So cluster analysis is also called as unsupervised learning. Unsupervised means we cannot know that how many clusters can be formed. Okay. So in this data, in this type of analysis, cluster analysis, basically there is a group data to form a new categories. Means you can form a new categories and basically these categories are formed on the basis of some criteria like similarities, how many similar data items are. We can also say the distances between the data points are also measured. So there are various types of the clustering algorithm, and these clustering algorithm are used for the different purposes. Basically, if we broadly say that how many types of cluster analysis are there, so there are basically 3 types of the cluster analysis that is not mentioned in the PPT, but I told you, I am going to tell you that first is called as a partitioning based cluster analysis. Second is called as hierarchical based clustering, and third is called as density based clustering. Okay. So I am going to cover 3 algorithms. One is a partition based, one is a hierarchical, and the another one is a density based. Okay. So what do we mean by partition? Partition means we have to divide the data item into a different cluster on the basis of the distances. Okay. The second is a hierarchical clustering, that we see that the hierarchical organization of the designations. We can also see the web page structure. Web page structure is also a hierarchical structure. So to perform the clustering in web pages analysis or the web mining, we have to use the hierarchical clustering. Okay. And the next one is called as a density based clustering. Density means how similar items with each other, and how close with each other. On the basis of the closeness, we have to divide the data into a clusters. So the criteria in all the algorithms are different. In partition based, dispensive method are used. In in hierarchical, the hierarchical structure is used, and in the density base, the closeness or the association between the item is used. So there are different algorithms. For partition based, we are mostly use the algorithm that is called as K-mean clustering algorithm. And for hierarchical clustering, we are using a hierarchical clustering. The name is also hierarchical clustering, but the in this we have to make a one diagram to show the hierarchy, that is called as a dendrogram. Okay. And the third is a density based clustering algorithm. The name of this algorithm is a DBSCAN. Okay. So I am not changing the slide. I am just telling you because that is not mentioned in the slides. Basically, the someone is means Parveena, you are telling give me one question. Basically, that question is based on the Python. Okay, but the same procedure we can use in the R. And this, yes, this data set is very famous data set. That is a Titanic survival data set. Okay, and in the Titanic survival data set, we can apply the clustering algorithm. But the data set, this Titanic data set is a very data set that is a very dirty data set. We have to use a lot. We have to apply a lots of the cleaning the part in that data set, and after that we can use a clustering algorithm. Okay, let first means run this clustering algorithm, K-mean clustering, with some very means familiar data set where cleaning is not used. And after that, I am going to explain with this Titanic survival data set. Okay. So let's begin this K-mean clustering. So for clustering, first you have to understand that the data set has only independent column. There is no dependent column. It is our assumption. Okay. If there is any dependent column, then we have to remove that column. Okay. So first of all, what are the different packages we require for the cluster analysis? I have to also check that these are available with me or not. So I required two uh, packages, cluster and cluster. Okay. First, we have to understand that what type of results we get in clustering. Okay. So in clustering, we get a graphical results, first of all, because we don't know how many cluster are going to form. If I give, there are make two cluster, the algorithm make two cluster. If I am giving make three clusters are developed by the algorithm. And we have to visualize these results. So in clustering, visualization is very important part. We have to visualize all the results. In classification, visualization is not as much as important as compared to the clustering. Okay. So let's first install this package cluster R. Okay. Installing. I required one more package cluster. Okay. These two are available with us. So let's check these are installed or not. So you can see this cluster and cluster are both are installed. Okay. Now to perform the k-mean clustering algorithm, I just use this iris data set only. And as I told you yesterday that if I give here iris, then I get a 5 point. Okay. But I also told you today that for clustering, we don't require this last column. Okay. This is precise. Because we don't know how many clusters are going to form. How many labels can be defined. So for that, our first step is I have to remove this column. Okay. So for removing this column, I make a new variable that is a iris1 and remove the column. Which column? Fifth column. Okay. So I write here minus 5. What is this comma meaning? I already told you yesterday that all rows means we have to use all the 150 records. If you remember in classification, what is our first step? Our first step is to divide data into two parts. The first part is we called as training data set and second we called as testing data set. Why we divide into two parts? Because the model developed by the algorithm, we have to test how much percent it gives you an accurate result. That's why we required a data set for testing. In clustering, there is a no model is developed. Okay. If you give algorithm that please form a 3 clusters from that, then it gives you a 3 cluster. And according to that, accuracy is maintained. If you give 4, then 4 are given. 4 clusters are formed. Okay. So you cannot identify in one trial that how many clusters are good for this data set. You have to do error and trial. Minimum you have to make a 2 cluster, then you have to try. Okay. Then how many cluster you can form from a data set? For example, in this iris data set, I have total how many rows? 150 rows. Means how many cluster I can form? At least 149 cluster. At least. Because if there is a one data set in one cluster, we can data in a one cluster, we can make a cluster. It is not compulsory that we require 10 data for 20 data to make a cluster. Okay. So our means we don't have to divide data in any clustering algorithm. We have to use the whole data to make a cluster. Okay. Now, as this clustering algorithm is also using the random sampling to make the clusters, if you want to achieve means develop and fix results, then you have to set the seed. Okay. If you don't want to set, you don't set the seed. So let's understand how these clusters are formed using the k-mean clustering. For making the clusters using k-mean clustering, you have to use this method k-means. Okay, you have to pass here the data set. Okay, which data set? The data set having no dependent column. In iris1, if I print here iris1, okay, you can see what you get in iris1. Only first 4 columns. Okay, the last column we don't have, because for clustering we don't require this column. If that column is already available, then the classification is the best option. Okay, now to apply the k-mean clustering algorithm, we have to use this method k-means. We have to pass the data set having only independent columns. Then we have to pass that how many number of clusters you want to form. Okay, the minimum value of this center is 2, because if you pass 1, then what is that meaning? All data points in one cluster. So there is no requirement. I already tell you yesterday that what is the meaning of set.c. For selecting the samples to make a cluster, there are 2 options. Either we select first row, then second, then third, then fourth, then fifth. This is our sequential order. Okay, but mostly algorithm use what method? Random method to select a row number. Means we are not going sequence wise. So we are going randomly. So randomly, if I am running this program first time, it might be possible the first row we get is a 4, row number 4. When we again run this program in second time, we get a row number 500, for example. So every time if my starting point is changed, then the algorithm results are different. So if you want to fix your results, then you have to use set.seed. Means the type of seed you are given to algorithm, always algorithm gives you a same result. Understand? Okay, and you can pass you can pass anything here. This is not fixed 240. If you want to pass 1, you can pass 1. If you want to pass 1000, you can pass 1000. You can pass any integer number in that, but that integer number is play a important role to decide the row number. According to seed, row number is changed. But if your seed and my seed is same, then you and me both getting the same result. If your seed and my seed is different, there is a probability that you get different result, I get different. Understand? Okay. So, and from where to start? For that, we have to pass n start. Okay. You can also change this, but this values lies to means the maximum value here you can pass is a total number of rows in your data set. For example, in our data set, iris data set, we have total how many rows? 150 rows. So we cannot pass n start here greater than 150. Okay, but if you want to change this 10, then you can change this 10. Understand? Okay. Now, if I run this code and print this results, so you can see that the available results. Okay. So you can see that total data is 150 and it divides row number 1 to cluster 2, row number 2 to cluster 2, row number 3 to cluster 2, row number 77 to cluster 1, 78 to cluster 3. You can see that 3 clusters are formed. 1, 2, and 3. The names are not given. Okay. For example, if I pass here the number of cluster 2, what is the changes in result? You can see 1, 2, 1, 2, 1, 2, 1. Means only 2 clusters are formed. For example, if I change here 4, I want to make a 4 cluster, not 3. Then you can see 1, 2, 3, 4, 1, 2, 3. Okay. Now, how we can decide what we pass? We pass 2, we pass 3, we pass 4 or 5. This is depending on your experience, that how you can click for accurate value. Because this is an error and trial method, you have to just try for different values, and on what value you give some better result, that value you have to choose. Okay. For example, if I am making a 4 cluster, you can see that the sum of squares of the cluster is 91.6%. Okay, means rest percent is an error. Okay, but if I pass here 3, you can see the percentage is 88.4%. Okay, so on the basis of this centers point, on the basis of the number of clusters, these values are changed. And depending on your experience, depending on your requirement, you can make a cluster. Okay. Now, you have to verify that every cluster that are formed are in which group. So, you have to print this cluster parameter. Okay, you can see this these are the different clusters that are formed. Now, I already teach you yesterday that to check that how much percent results are accurate, we required one matrix that is called as a confusion matrix. To make a confusion matrix, we have to pass at least 2 things. One is a result obtained by the algorithm, and second is the original result. So we have a one column species where the original class labels are given, and we have 3 clusters. We have clusters that are defined by the algorithm, k-means clustering algorithm, and that are stored in this variable. So on upon using these 2 parameters, we can make a confusion matrix. Okay. So here you can how the results are interpreted, that if you see that there are 2 results of versicolor that are identified in 3. Okay, means that are the error, and there are 36 that are not Virginica but classified as Virginica. Okay, so these results are important, and we want to increase the accuracy of the algorithm. So if in original the class is Virginica, then here also there must be a Virginica class, but as we are using the algorithms, there are chances of the error, but we can reduce these errors according to our need. Now, as this is a clustering algorithm, we have to visualize the results. Okay, so for visualizing the result, what we have to use, 1 minute, 1 second. Hello. Okay. So for plotting the results of this classification algorithm, uh, as we are plotting only two-dimensional graph, so we have only two axes, x and y axis. So let's in x-axis, I take one column that is a sample dot length. In our original data set, there are four columns. So we cannot plot all four columns in a two-dimensional graph. That's why I am taking only two parameters. One is the sepal length and second is the sepal width. Okay, that is my x-axis. Okay, and in the y-axis, I have to plot the clusters that are constructed by the k-mean clustering algorithm. Okay, and this is the name of the plot. Okay, now if I run this, you can see there are three colors. It means three clusters are formed. Some are overlapped. It means that are error. Understand? Okay. Now, as I told you that for making a cluster, and using k-mean clustering algorithm, the distance method is used. Okay. So distance from where? So distance is from center. Okay, center. And this center is called here as centroid. For example, these red points have one centroid, this black point have one centroid, and this green point have one centroid. And on the basis of this centroid, the distances are calculated. Now, if you want to plot the centroid also, okay, then you have to plot this cusp plot. Okay, that is available with the package cluster R. Okay, this is available with cluster R. And here you can basically plot that the two columns like I take is a sepal length and sepal width. Now we have to plot the clusters value. Here I store this k-mean dot re and dollar cluster in a one variable. You can pass directly here also. Okay. If you want to show the lines, then you can give the lines value, means thickness of the line. Then if you want to give the shade, you can give shade, then color, labels. Okay. These are the different type of the customizations that we can do with the plot. Okay. Now, if I run this code, you can see that there is some changes in the graph. Okay, you can see these labels are given, these lines are given, and these are the cluster. You can see here, this is the cluster 1, this is the cluster 2, and this is the cluster 3. Okay. Understand everyone? Can I share you the script? If you are facing any problem, then you can ask me, okay? Okay. Everyone done this? So I can move forward. If you are facing any problem in running this code or there is some problem in understanding, you can talk to me. And this is also the name I am using. You can also use this petal dot length and petal dot width. It depends on you. Okay, but as we are making a two-dimensional graph, we cannot use all the columns because we have only two axes. Okay. Okay. So the second clustering algorithm that I discussed with you is a hierarchical clustering. Okay, where you have to divide the data set in the form of the hierarchy. Okay, like the company's hierarchy, the CEO, then CTO, then there are different managers. Then after managers, there are some junior managers. So this is a one type of hierarchical structure. So if you want to divide your data set in the form of the hierarchy, then we can use a hierarchical clustering. Okay. So how to perform the hierarchical clustering? Let me discuss. Okay. So to run this hierarchical clustering, um, I am using a one inbuilt data set. That data set name is a empty cars data set. This is a cars data set. Okay. Now I required a one package to run the hierarchical clustering because I have to make a one diagram that is called dendrogram, and I have to calculate the different type of distances, and for that I required a one package that name is DBSCAN. I already shared the script of the K-mean cluster. Okay. Okay. So for hierarchical clustering, I required a one package that is DPLYR. So I first install. Okay, so this package is already with me. So this package is updated. Okay. Now let I check that this package is available with me or not. So I write here. So you can see that this is available with me. I just click to load. Okay. Now I want to see that how this empty cars data set look like. So I just write this empty cars. This is a inbuilt data set of cars. Okay, so this is a data. So what this data set is? These are the labels of the data. Then the cylinder value, display value, HP value, gear, how many number of gears are there. These are the data set that is available. Okay. So on this data set, I am just want to perform the hierarchical cluster and divide the data to form a cluster on the basis of this classes data. Okay. So this is a whole data set. If you want to print first 5 rows of this data set, then there is a one method that is called as head. Head gives you a first 5 result of this data set. Okay. Only first 5. Okay. Now, to divide the data set into a hierarchy, we have to first find out the distance. Okay. There are lots, means various types of distances are available. Which script you are telling? Because this K-mean clustering I already shared to you. Can you please message which script you are telling? A priori. That I think I already shared. Okay, one second. A K-mean I already shared. Okay. Do you get? Sorry. There is a problem that I am sending to direct the messages. 1 minute. Huh? Now everyone get the scripts? Okay. Okay. So I am just telling you that to divide the data in the form of the hierarchy, there are lots of the distance methods are used, like Euclidean distance that is mentioned here, Manhattan distance, cosine distance, and the formula of all the distances are different. If you learn theoretically, then you can understand these are the mathematical formulas, and on the basis of these formulas, the distances are calculated. Okay, but in algorithm, we have to pass only that which distance you want to use. Okay, so if your data set is a numerical data set, then mostly this median distance gives you a good result. Okay. So to calculate the distance between each data point to other data point, we have to first use this method dist. Okay. Then pass the data set, whole data set, and then pass which method you can use for calculating the distance. Okay. Now, if I run this, you can get a one matrix that is called as distance matrix. Okay. So you can see in the distance matrix that you can find out the distance between each and every uh, uh, dependent row to another. These are the distances. Okay. And on the basis of that distances, the hierarchical clustering is going to form a hierarchy. Okay. Now, again, in hierarchical clustering, the data set that are used by the algorithm is random. So, to achieve the good results or to achieve the same results, we have to use this seed method. Okay. So here also I said that this seed to 240. If you want to change that, you can change. You can make okay, one or two that you the seed that you want. Okay. Now to make a hierarchical clustering, we have to use this method H plus that is available with this package DPL by. Okay. Now here you have to pass the distance matrix because hierarchical clustering is used to make a hierarchy on the basis of the distance, not on the basis of the original data. And to calculating the distance from one to another, which method we are using here, that is the average method. Okay. Now to plot this hierarchical clustering, and I already told you the hierarchical clustering plot is called as a dendrogram. we use this method plot, and here you have to pass this hierarchical clustering variable. Okay. Now, if I run this code, you can see this hierarchical clustering is formed. Okay. You can see that first two clusters are formed. Then from two cluster, 1, 2 means 4 cluster are formed. And after that, it divides the data into a cluster and achieve till dividing the cluster so that every data points are covered in a cluster. Okay. So this chart is called as dendrogram. That is formed with the help of the hierarchical cluster. Okay. Now, if you want to make a line, means here you can see the height of this is 0 to 250. If you want to make a one line between this dendrogram, then you can use a one method that is called as AB line. Okay, this is AB line. So in AB line, what the height you can pass, you can draw a one line at that point only. Okay, this is used to divide the hierarchical cluster or to divide the tree by a certain height. Okay, so if I run this code, you can see a one green line. Okay, and what I pass is 110, so you can see that this is 100 and this is 110. You can change also this. For example, if you want to divide or cut your tree at the height 100, then you can also. Now you can see there are two lines. One is with 100, one is this with 110. Because I am plotting in the same graph, that's why this is showing. Now if I run again, then you can see only one graph is showing. Okay, this is 100. Understand? Now this AB line is used to cut your data in a basically vertical form. But if you divide your tree in a horizontal form, then this cut tree is used, and how many cuts you want to make, that you can pass here. Okay, for example, I want to cut this data set into a 3 different parts, then you can pass here 3. Okay, now if I run this, you can see changes. 1. Okay, that is not plot, but that is seen here. If I want to plot also, then you have to run this. Okay, you can see this. This is 1, this is 2, and this is 3. Okay, so it divides the dendrogram into a 3 part. You can also cut horizontally as well as vertical. Okay, if you want to change this, you want to divide into a 4 part, then you can also do this. You can see here, this 1, 2, 3, 4. Okay. So depending on your requirement, you can make a number of clusters using the hierarchical clustering. Understand, everyone? That we can also perform in the IRIS data set, any CSV data set, we can use any data set and perform this type of clustering. Okay, can I share you script this? Everyone done this? If you are facing any problem and any difficulty, not understanding the each and every line of the script, you can ask me. Okay? Because when this is I am doing this with only one data set. If you are doing with another data set, it might be possible the number of clusters, the number of the distances matrix, and everything is different. Okay, because everything in data mining is depend on the data only. If your data is changed, everything is changed. That's why you have to understand each and every line, that if you are going to develop a code for another data set, then what are the changes you have to do, and what are the things you have to very importantly know, that these if we changes this, then there are lots of changes in the results. Okay, so I'm going to share this script to you. But please remember all that in each and every type of clustering algorithm, the visual representation is important, or I can say it's compulsory also. Without visual representation, you cannot perform a clustering. Because in clustering, we have to show that how many clusters are formed, what are the things they going in a one cluster and another clusters. We have to visualize these things. Okay. So now I'm going to cover the third type of the clustering algorithm, that is called a density-based clustering algorithm. Okay. So I already discussed you two different types of the clustering. One is a partition. We have to divide data into a different part. Then second is a hierarchical. We have to divide data into a hierarchy form. And third, we have to divide data into on the basis of the density or the association. Okay. So what is when we are using this k-mean clustering, and when we are using this density-based clustering? Okay. So if you remember, in k-mean clustering, what are the different types of graph we are developing? Okay. So okay, so you can see that this graph is what. If I am going to tell you that what is the shape of this cluster. Can you identify the shape? Anyone please message me. What is the shape of this cluster? Okay, so the shape is predefined. We know that square, rectangle, triangle, these are the different shapes. But If I am I am going to tell you that it might be possible that the name of the shape is not predefined. For example, the shape of the amoeba that we discuss in the botany lecture. So you can understand the shape of the amoeba is always changing, not fixed shape, and the name of the shape is also not defined. So in that cases, if the shape of the cluster is not predefined or we cannot define the name of the shape of the cluster, in that case, the DBSCAN or the density-based clustering are used. Because the main feature of the density-based clustering is that you can make a cluster of any form, any type that name are not defined. Okay, so there is zigzag type of clusters are also available. So that is possible with the DBSCAN, but that is not possible with the K-mean clustering. In K-mean clustering, mostly the cluster we are forming having the shape either oval, either circle, either ellipse. These are the shapes are mostly available. Okay, but different type of shapes are not possible, or the shape that name is not defined is not possible with the K-mean clustering method. And for that cases, we have to use the DBSCAN. Okay, so it depends on you. It depends on the data that which type of clustering gives you a good result. On the basis of that, we can use the type of the cluster. Okay, so now I just open the script of DBSCAN. Okay, so the name of the algorithm is a DBSCAN. Okay, that I am going to explain you with the IRIS data. So for this DBSCAN dataset, we also required one package. Okay. So the package name is FPC. Okay, so we require this package to run this DBSCAN algorithm. So let's first download this package. Okay, so this package is installed. Now this is a inbuilt dataset IRIS data I'm using. This str gives you a structure of the data set, and this is I use for downloading the package. Okay, now let I check this package is installed or not. I write here FTC. You can see this is the installed. So I just click to load this. Okay, now as this is a clustering, so we don't require a dependent column. So as we already done in the K-mean clustering, I remove this column from the IRIS data set and store in a new variable IRIS_1. Okay. Now DBs can also use a random sampling to get the data points. So I set seed here. So you can change the set seed value according to you that we want. Okay. Now to apply the DBSCAN algorithm, we have to use this DBSCAN method that is available with the FPC library. Okay. Now let's understand the parameter of this DBSCAN algorithm. So what are the different parameters we are using? First is a data set having only independent column. The second is the EPS that is pronounced as epsilon value. And the second is the minimum points. Okay. So on the basis of these two parameters, DBs can decide how many clusters are going to form. Okay. Let's first understand what is minimum points. This minimum points is a factor that gives you that in every cluster there are minimum 5 points. If in a cluster there is a minimum data points less than 5, then the algorithm is not going to form a cluster. Okay, first step. Second is the epsilon value. This is the one mathematical or the probability value that is calculated by the DBSCAN algorithm, and it gives you an association between the data points. So if in a one cluster there are 5 data points and the association value of each and every data point from the other data point is either greater than or equal to 0.45, then it is covered in a one cluster. Otherwise, that point is not covered in a cluster. It might be possible that is covered in another cluster. Okay. So for DBSCAN algorithm, there are two important parameters. One is the association that is represented by the epsilon value. And second, how many minimum points required to form a cluster. Okay. And this gives you a DBSCAN clustering result. As like k-mean clustering algorithm, if you want to print that which data point is covered in which cluster, then you have to print this DBSCAN $cluster, like we plot k-mean dot cluster. Okay, so if I run this code, so you can see there are mostly there are 3 clusters are formed, and the number of the clusters are 0, 1, and 2. In k-means we see 1, 2, and 3. But here the numbering begins with 0. So 0, 1, and 2. But how many clusters formed by the DBSCAN algorithm? That is 3 clusters. Okay. Now to show the basically confusion matrix, we use this table method. Here, this is a result predicted by the algorithm, DBSCAN algorithm, and this is the original result. Okay, so let's make a confusion matrix. You can see this is a confusion matrix. Okay. Now to plot the data sets, means DBSCAN clustering data set, we have to use this method plot. We have to pass here the DBSCAN underscore CL, that is a variable formed when we are making a clusters. Then this is the original data set, and this name equal to DBSCAN is the name of the graph. Okay, so I am making here a 2 graph. You can see this. This form a graph for each and every data point with other point. We have 4 parameters: sepal dot length, sepal dot width, petal dot length, petal dot width. Okay. And you can see here 3 types of clusters of different shapes. Okay. So this is a sepal dot length with sepal dot length. So you cannot see any value here. This is a sepal dot length with petal dot length. So in the diagonals, you don't see any values. But each and every column is associated with other column. Hello. Okay. So these type of plots are developed by the DBSCAN algorithms. Okay. Here only I change this name of the plot. If I run this, you can see this name of the plot is changed. Okay. So this name is used for only to give the name of the particular plot. Okay, so I can bring the this here. Okay. Understand this? You can also do a different type of customizations in the graph, but these are the basic graph that you have to draw when you are applying these algorithms. Okay. Everyone understand? If there is a problem, you can ask. Okay. I'm telling you many more time. Um, can I share you a script of this DBSCAN? Okay, as you are telling about the evaluation of the clustering, mostly evaluation is done when we have a training or testing data set. Okay, in each and every clustering, if you see how many cluster I have to form is given by me only or given by the programmer only. So there is no need of the evaluating, because you are telling that give me a 3 cluster, algorithm is giving you a 3 cluster. Okay, but there are many tools available, like there is a one data mining tool, Orange. There is a tool Veka. Okay, because we are here doing a hard coding, so we have to error and trial. We have to pass different values to evaluate that confusion matrix doesn't have the false positive and false negative values. Okay, but there are tools available where the tools give you various options that if the number of cluster is 3, then the accuracy is this. 4 accuracy is this, 5 accuracy is this, and according to that, you can choose that how many number of clusters you want. Okay. Basically, clustering is used to divide the data set into a part. Okay. For example, there is a student. We can divide a student on the basis of gender, on the basis of complexion, on the basis of the hair color. There are lots of the things are there. Okay. So we cannot form means how many clusters we want to make. So evaluation of clustering is not mostly done in the papers, research papers you see having the clustering algorithm implementation. You cannot find this accuracy, precision, recall value. These are only available with the classification, not clustering. Okay. And some algorithms are also available that are used both for classification and clustering. Like there is a one algorithm CART, C-A-R-T, that is used for both classification and clustering. Okay. everyone received this script? Okay. So in classification, we learn two algorithms. That is a decision tree and naive-based classification algorithm. In clustering, we covered three algorithms. That is a k-mean clustering algorithm, hierarchical clustering, and DBSCAN algorithm. And we covered one algorithm of association and correlation analysis. That is the a priori algorithm. Okay. But there is a one very important algorithm also available, that is called as a random forest algorithm. And this random forest algorithm is mostly used for classification as well as prediction. Okay, and this algorithm I can say is a better version of the decision tree algorithm, uh, where you can get the good result as compared to the decision tree. So what is the difference between decision tree and random forest? Let's first discuss. So if I tell you what is the difference between forest and tree, so you can uh, you can tell me that a tree means only one tree, but in forest there are lots of trees. Okay, so if uh, I want to make a more than one tree and find out the average accuracy on the basis of all the trees developed by the algorithm, then we can use this random forest algorithm. Because in one time making a tree, there is a chances that either you get a good result or bad result. But if you run that algorithm 10 times, 20 times, 30 times, then the average is always better as compared to the one time run. So for that reason, mostly people are using the random forest algorithm to get the better accuracy and to justify the result in a better way. Okay, so that's why we are using this random forest algorithm. So I am just going to explain you this random forest also for classification and clustering. Okay, so I this for running this random forest algorithm, we required two packages. One is the CA tool, second is the random forest. CA tool we already installed yesterday, so we not required today, but we required a one package, that is a random forest. So let's first install this package random forest. Okay, so this package is installed successfully. Now I comment this. So I am using the same data, that is the iris data set, to run this algorithm, random forest. Okay. So this is the classification algorithm. So what are the steps we are using? We have to first load the data set, divide the data set into a training and testing part, then use the training data to build a model, and testing data is used to predict the model, and then we have to find out the evaluation parameter like accuracy, precision, recall. These are the different evaluation parameters. Okay, so I load this data set of the data set. Okay, now what is my step? I have to use this sample.spread that we already used yesterday to divide the data into a training and testing part. And here I am going to use the ratio, that is a 70-30. You can see here I am not using this set.seed here, but if I am not using, you also know that I am getting the different result every time. Okay, so if you want, we can use here also set.seed. Okay. So let's first load the data. Then get the structure of the data. And now I have to load this libraries. So CA tools. Now random forest. Okay. Now I set my seed. Divide the data into a training and testing part, and now I print this data. Okay. So you get that this data set gives you a true and false result. So what do we want that all the true results comes under the training data and all the false result comes under the testing data. So let's make a training data and testing data. Okay. Now here I am using this set.seed. So if I am using previously, there is a no need to set the seed again. Okay. Now we have to apply this random forest algorithm. For random forest algorithm, we have to pass that independent column, dependent column, and how many number of trees you want to make. Because this is a forest, so we have to pass number of trees. So what is our training data set in training? For example, if I print train, what you get? You get the different record having 5 columns. But what is X? X is the independent columns. Okay. So here I have to remove this column. And for the Y, that is a dependent column, we have to use only the last column. So I write with $sign. Okay. So how many number of trees you want to make? For example, if I want to make 100 trees. Okay. And then it gives you the classification result on the basis of the random forest. Okay. So it gives you what gives this? That number of variables tried as each split is a 2. The estimate error rate is a 4.44%. Means rest of the data is classified correctly. And this is our confusion matrix. Okay. Means Sentosa is classified with no error, while versicolor is classified with 0.06% error, and Virginica is also classified with 0.06% error. Okay. Now, to predict the result, we want to use this predict method where I have to pass this, the value predicted by the model and the actual data. So, in the testing data, we have all the columns. So, all the columns, independent column, I have to pass. Okay. Now, to print the confusion matrix table, I can use this table. Then for confusion matrix, we have to pass 2 values. One is a value predicted by the model and second is a actual classes given in the data set. So in the actual classes, what are the data set given? That has a row number, column number 5. All rows, column number 5. And these are the values predicted by the model. And this is confusion matrix. Okay. Now to plot. Means how to plot means we have to check that when we are making a 1 decision tree, what is accuracy second, what is accuracy third, what is accuracy and 100, then what is accuracy. Okay. 1 minute while this, okay, the margins are too large. So for example, if I pass here 500, then I check. Anyone can check the plot is plotted in your system. One minute. There are some customization required to set the length of the figure. Okay, so if I set the figure length, we have to just customize this, how to fix the size. If this is possible in any system, then please let me know if you have already done. Can I share the script? Anyone can run in your system, because it is also dependent on the system configuration that the graph is plotted with the customizations or not. Can I share you the script, and please check anyone in your system if the plots are available to you. Can anyone check on my behalf? Because this is not a error. Actually, you can see that the margins are the too large, and that is not fitted as per the system configuration. That's why we are not able to see. Anyone can please check and let me know the error is also coming, or the graph are able to see by you. Uh, do anyone done this? Hello? This is a one, you can see that this is a one type of the graphics error. So you have to check the graphics because sometimes the graphics are not supported. That's why we are not able to see the graphs. Let I try. Okay, this is possible. The values are showing, but we cannot able to plot. Anyone has done? Please respond if possible, because this is a graphics error. If you have a better hardware configurations for graphics, then we can able to see the graphs. Hello? Please respond if possible.
So you mean voice communication, ma'am?
Yes?
They can use a chat window.
Yes, I am just telling for the chat window because in
Okay,
my
okay, fine,
system the
fine.
graphics card is not there.
Okay.
So it might be possible, that's why this error is showing. So if anyone run this script and check in their system that it is running perfectly or not, and give me the answer. Yes, this script is running fine in your system. Okay, okay. If possible, can you please share the graph in chat window? Save as a PDF or a PNG file and share in a chat window if possible. Okay, let's tell you that what is this variable importance. So this variable importance is very key part of this random forest algorithm. As we know that in iris data set, there are 4 independent columns, okay? But each and every column importance is not same. So this variable importance plot told you that sepal dot length, sepal dot width, petal dot length, and petal dot width, which column plays a very important role to classify the data set. It might be possible the sepal dot length is not as much as important than petal dot length. So this type of analysis is done with the help of the variable importance plot. Okay. Now what this gives importance? This gives you a only value. Okay, not plotting. This gives you a only value. For example, if you can see here, there are 4 columns. What is the importance of petal dot width? That is a 26 point something. Petal dot length 25 something. Sepal dot width 1 point and sepal dot length 6 point. So what we observe from this result that out of 4, petal dot width has the highest contribution to classify the data set rather than other columns available. Okay. So if you want to ignore, for example, if you want to drop any column or your data set means number of columns are very high in your data set, on that case, if you want to drop, then which column you want to drop, it depends on the importance. If the column is not very important to you, then you can drop. Okay. Now, someone share me their file. Okay, so you can see this figure that is developed by this variable importance plot. You can see that here the total number of, in x-axis, total number of tree. We pass the total number of tree as 500. Okay, and this is the error. Okay, so you can see when the number of tree are less, the error are high. But as you increase the number of trees from 100 to 500, your error is stagnant. That is 0.05. It means that if you are developing a number of trees more than 100, then there are chances that we get the less error as compared to the if you are developing a tree number of tree less than 100. Okay, so it gives you that how many number of trees are sufficient to get the accuracy as per your requirement. Okay, and in random forest, mostly at one stage, when you are growing the trees, you get the stagnant result in terms of the error. Okay, everyone understand this? So this is all from my side. So during this all 3 days session, if you find any type of difficulty, any help, any suggestions for your research and for your lab works, then you can ask, please. Okay. Okay, regression. Okay. So basically, regression is used for the prediction. Okay. So, and there are various types of regressions like linear regression, multiple regression, logistic regression. And basically, if I talk about the logistic regression, so logistic regression is mostly used when you have dependent variable with binary values like 0, 1, true, false. Okay. For example, mostly people are using logistic regression to detect fake Instagram profiles, to detect fake Facebook profiles on the basis of their activities. In that cases, there is no middle value. Either the profile is fake, either not fake. Okay, and if you want to predict that which is fake and which is not fake on the basis of the independent, then in that case you use logistic regression. But in linear regression and multiple regression, the outcome variable or the dependent value is not binary. Okay, and in linear regression, we have at least one independent and one dependent column. But in multiple, we require more than one independent column and one dependent column. Okay. Any more questions, please? I'm waiting for more questions. If anyone have questions, I already shared my email ID to yesterday. So if you find any query in future also, you can just mail me. Okay, I'm trying to help you. Okay, I'm waiting. Any more questions?
So thank you, ma'am. Thank you, participants, for the today's session you joined this. So we just posted one certificate form. You can submit the form medical certificate within 2 days, the day after tomorrow. Anyway, you will get an updates on the WhatsApp group.
Okay. So you are handling the data mining subjects. That's very good. And if you find any difficulty, means if you are you want to do data mining using R, using Orange, or any Veka, any other tool, then also I am going to help you. So you can just mail me first. Okay. Yeah. Okay. Thank you, sir. That's all from my side.
Thank you, ma'am. So can we wind up the session? You will get recordings by today itself for tomorrow morning.
Okay, sir.
Yeah, thank you.
Yeah. Okay.
Thank you, everyone. And
thank you, everyone.
thank you from A to Learning Hub. Thank you very much.